discussed how to find out the root of any complex functions. So these two lectures are very important for VSC semester 4. Okay, you already know my lectures is from basic to advanced. I'm actually follow this kind of trends. Basically, when you cover all my course in details, then you are eligible for your semester exams and as well your IIT JAM, JEST and TIFR exams also. Okay, so let's start the video. Myself Metun Patro, and I am a PhD student at Noiser Earth and Planetary Science Department. Okay, and today's class is based on basically this is the semester 4 lectures, and today's class is basically let's say argument calculations. Okay, today's class is to discuss the argument calculations and also the principal argument calculations, and we have to cover some of the previous year IIT JAM problems also. Okay, so let's start with some basic explanations of complex number. Okay, so you already know so we are already know this is the complex number. Okay, so any kind of complex number actually represented like a z equals to x plus iy, and here x is a real number and y is a kind of imaginary part. Okay, is a also real number but it's with imaginary parts, and from the complex number z equals to x plus iy. Okay, from the complex number z equals to x plus iy, so the angle made with the positive real axis is called basically argument of this complex number. Okay, so argument is calculated, argument of z is nothing but basically theta. Okay, so theta is kind of from this complex number is calculated from tan inverse y by x. So basically so argument of theta, so argument, okay, so argument of z that is equals to theta, and it is kind of tan inverse y by x. So for any complex number you have to calculate the argument of any complex number is nothing but theta. It's a kind of theta, and theta is nothing but tan inverse y by x. Okay, I have to discuss here the very important part. So this is now we have to focus the polar form of complex number. We already had covered this part. Okay, so this is the also we already know the complex number is represented x plus iy. So we had the relations between complex polar coordinate and Cartesian coordinate, right? So this is equals to x equals to r cos theta and y equals to r sin theta. You just put here, so we get r cos theta plus I r sin theta. Okay, I r sin theta, sorry, I r sin theta, and we are taking common r, so cos theta plus I sin theta. So in polar coordinate any kinds of complex number can be written as a like of r equals to cos theta plus I sin theta, and r here r is called modulus. Okay, here r is called modulus, and r can be calculated is equals to x square plus y square. Okay, so basically so from this expressions we can calculate r equals to x square plus y square. Okay, r equals to is equal to x square plus y square. Okay, so you have a complex number. Let's say you have a complex number z equals to x plus iy. Okay, x plus iy, and you want to express this complex number in polar coordinate, then you first calculate r, and that is nothing but modulus of z complex number, and it is nothing but x square plus y square, and you get some constant value, and then you have some and then it's multiplied with cos theta and sin theta, and then you convert x and y into polar coordinate system, and then you can find this polar coordinate in polar coordinate system the complex number. Okay, and now this expressions is written as basically z equals to r cos theta plus I sin theta. Okay, and from the Euler's formula, okay, you have to use here Euler's formula, that is equals to r equals to a to the power I theta. So in polar coordinate system, complex number could be written as a z equals to r e to the power I theta. Okay, and theta here is called here theta is basically sorry, not capital A, that is basically argument of z. Okay, it is called argument of z. Okay, and it is nothing but tan inverse y by x. Okay, so actually I have to discuss here two simple applications, two simple case of complex number actually, or in Cartesian coordinate system and also in the polar coordinate system. So this is a kind of basic explanations. Okay. Okay. Next, to discuss the argument diagrams actually. Argument diagram. This is the argument diagrams. So this is the imaginary axis. Okay. This is the y axis and this is the real axis. X axis is real axis and this is the imaginary axis, y axis. And here this is the complex number z x plus iy, and this complex number z value makes an angle real makes with an angle real axis, and this angle makes an angle theta. Okay, here basically theta is nothing but angle of z with respect to real x axis, or we have to say this is real axis. Okay, theta, and theta is called here, that is the argument, not capital A, that is argument of z. Okay, theta. Now from this diagram easily say, okay, let's say let's try to understand that part actually. Okay, okay, yes, let us consider this is a complex number z equals to x plus iy. Okay, and this complex number makes an angle with respect to real x axis is equals to, this is the real axis and this is the imaginary axis. Okay, imaginary axis with angle theta. But theta, okay, I mean, what is the argument, what is the actual argument of any complex number? Okay, we have to understand this part actually. Just clear, this theta have a value if the complex number in the first coordinate, then theta have a value. If the complex number in the second coordinate, then theta have the another value, this is pi by 2 plus theta. Okay, and if the complex number in the third coordinate, then theta have another value. If and again the complex number in the fourth coordinate, then theta have another value. Okay, so you have to calculate, always calculate from the real axis. Okay, from the real axis. So now we have to generalized form of the argument of any complex number. Okay, generalized form of the argument of a complex number. Its argument of any complex number, it's not exactly theta. Okay, it's not exactly theta, it's a kind of theta plus integral multiple of 2 pi. Okay, theta plus integral multiple of 2 pi. Okay, so from this argument diagram, finally conclude here that the argument of any complex number is equals to, that is not exactly theta. Okay, so argument of any complex number is theta equals to 2n pi. Okay, and n must be here n must be ever 0, plus minus 1, plus minus 2, plus minus 3, and so on. Okay, so just keep in mind, for any complex number, okay, for any complex number, argument of this complex number is nothing but theta. Theta is nothing but tan inverse y by x plus 2n pi, and n have some kinds of value like and 0, plus minus 1, plus minus 2, and plus minus 3 so far. Okay, I think you understand what is the argument, what is the argument of any complex number. Okay, that's fine. Let's discuss here. This is the principal argument part. Okay, so this is the argument of any complex number. Okay, that is theta equals to 2n pi, and here n equals to 0, plus minus 1, plus minus 2, plus minus 3, and so on. And here this theta, okay, and this theta is called capital argument of z, okay, capital argument of z, this theta. So here argument of z, this is called principal argument. Okay, this principal argument of z, we have to discuss in details also what is the how can I calculate the argument of z. Okay, principal argument, that is called principal argument. Okay, that is called principal argument, and this is called only arguments. This is called argument. This is called principal argument and arguments. So principal arguments have value minus pi to plus pi. Okay, it is limited within minus pi to plus pi, but argument of any complex number, it is not limited. Okay, it is not limited. But argument of theta, principal argument of any complex number is limited minus pi to plus pi. So you just remember this two concept. Actually, argument of z is nothing but theta plus 2n pi, and principal argument is limited within minus pi to plus pi. So there is no any kinds of okay, this is, so argument of z is nothing but, so we have to calculate here, you have to just finalize two things. Argument of the complex number, that is equals to theta plus 2n plus, and principal argument of zeta, theta z is equals to theta, and theta, this theta have a value minus pi to plus pi, but principal argument value is limited within minus pi to plus pi, but argument value is not limited. Okay, so just clear, here argument value, it is nothing but theta plus 2n plus, and principal argument value, it's only theta, and its value limited only minus pi to plus pi. Okay, just in the next slide I have to discuss in details also, just clear. Okay, yes, this is a very good approximation here. Argument of let's try to some theorem also, arguments of a complex number, that is a kinds of theorem. So let us consider there are two non-zero complex number. Okay, two non-zero complex numbers z1 and z2, then the argument of their product, let's say z1 and z2, the product of z1 z2, we have to, this is also a complex number. Okay, so what is the argument of this product, of their product, and what is the principal argument of their product? That is a very, very important part I have to cover here. Okay, so let's say we have a two complex number z1 and z2. Okay, and their product is another complex number, and we have to calculate the argument as well as the principal argument. So the theorem is the argument of their product is the sum of their argument. Okay, sum of their individual argument. So argument of Z1 and Z2 is nothing but argument of Z1 and argument of Z2 plus 2 n pi, and here 2 and pi represent the integral integer of 2 pi. So basically n is equals to plus minus 1, 0 plus minus 1 plus minus 2 plus minus 3. So this is the kind of theorem of arguments of two product of two complex numbers. Okay, so it's a very easy case. Yes, so let's definitions of principal argument, that is very important. I would understand here also in details the principal's arguments. Okay, let us consider Z be a complex number, okay, non-zero complex number, that is nothing but x plus iy, this kind of. Okay, the principal argument of Z denoted by capital A arguments, that the capital A starting with capital A, okay, arguments starting with capital A is unique value of the argument. Okay, this is a unique value, right? Principal argument means this is a unique value, it's a kind of one value, but argument is not kind of unique value. Based on the n, different n, we get different value for argument, but for principal argument it's a kind of unique value of the argument of Z. Okay, it is a unique value of argument Z within the range minus pi to plus pi. We just clear here. Let's say you have a complex number Z. Okay, let's say you have a complex number Z, and this complex number have a argument's value. Argument of Z is equals to theta plus 2n pi, right? So you have to consider when n equals to 0, argument of Z is equals to theta. When n equals to 1, argument of Z is equals to theta plus 2 pi, right? And when n equals to minus 1, then argument of Z equals to theta minus 2 pi, and so on, right? So for a complex number there are many arguments, right? Many arguments means the complex number, this complex number, based on different x value and y value, you can get many different x and y value, you get different arguments actually here. But now x and y value, okay, some complex number is located first coordinate, some complex number will locate it in second coordinate, third coordinate, and so forth. So basically that's based on this x and y value, we get different theta value. That's all different theta values are called here the arguments. But the one unique value of the argument of that argument is called basically principal argument. So what are the unique value? How can you choose the unique value? Okay, and the unique value is located within minus pi to plus pi, definitely. Okay, minus pi to plus pi, and that value, that unique value is called basically principal argument. Okay, so this is the definitions of principal argument. Okay, and you already know argument of Z is equals to theta plus 2n pi, and the value of theta is basically satisfy this relations minus pi to plus pi, and it is called so this is the definitions of principal argument. I hope you understand it better. When you deal some kinds of problem, then you will definitely understand proper way. Okay, so I hope you understand what is the basic difference between arguments and principal argument. Okay, arguments have many values. Okay, arguments have many values. Based on this, the complex function, complex number is located in which coordinate, right? But the principal arguments have a only unique value, and the unique value must be lie within minus pi to plus pi. Okay, I think you understand. Okay, very good. Let's take this is a kind of theorem. Okay, it's a kind of theorem, and we have to cover here this is kinds of MSQ problems. Okay, argument of product of complex number. So let us consider Z1 and Z2 be two non-zero complex number. Okay, these two are basically non-zero complex number. So which of the following statements are correct? So argument, product of argument, principal argument z1 and z2. Okay, so it's a node, it's a unique value. So it means basically argument of z1, principal argument of z1 and principal argument of z2. It's not any kind of further additions of 2 and pi. Okay, but for arguments, okay, for arguments of z1 and z2, it must be argument of z1 plus argument of z2 with 2 and pi. We already discussed. So here is 4 option. Principal argument of z1 z2 is equals to principal argument z1 plus principal argument z2 plus 2 k pi. No, this is a wrong statement. Okay, options B, argument of z1 z2 equals to argument z1 plus argument z2 plus 2 k pi. Yes, this is the correct statement. Now we have to discuss here the argument of z1 and z2 is equals to argument z1 plus argument z2. Yes, this is also correct. Here is written C also. Okay, and argument of z1 z2, no, this is the wrong statement. So this is the kinds of definitions of argument of z1 z2 and principal argument of z1 z2. Okay, very good. Let's take some problems. Let us discuss a very important problems also. Okay, and the problems is very important for your IIT JAM purpose. Okay, just keep in mind all the problems I choose here very important for your IIT JAM also, and also those aspirants will give the semester exams as well. उसके लिए भी lectures बहुत ही important होने वाला है, right? So lectures are very important. So just note down all the concept in details, right? Okay, let's start with the problems. MSQ the problems. Let us consider there are two complex number. Okay, so there are one complex number is z1 is equals to -1. This is a complex number, and another complex number is basically z2 is equals to plus I, and there are a product of these two complex number z1 and z2. So which of the following statements are correct? It's again a MSQ type question. Okay, you have to you need to calculate the argument and principal argument. Okay, let's try to solve this. So first of all, calculate the z, the product of this two complex numbers. Okay, so z is equals to z1 z2. So it is equals to z1 minus 1 into I. So it is equals to minus I. Okay, it means 0 minus I. So the complex number is equals to 0 minus I. So from so we already know z equals to x plus iy. So comparing these two equations, so x equals to 0 and y equals to not minus I, y equals to minus 1. Okay, now theta is equals to basically tan inverse y by x. Okay, so tan inverse minus y 0. So tan inverse infinity, not minus infinity, so it is equals to basically tan inverse tan minus pi by 2. Okay, so it is equals to minus pi by 2. So theta is actually minus pi by 2, and it is nothing but the principal argument. Okay, so we already know theta is nothing but the principal argument. So the principal argument, okay, that is nothing but argument of z. Okay, so argument of z is nothing but theta, and it is equals to minus pi by 2, right? Minus pi by 2. let's trying to calculate the uh, arguments, right? So to calculate the arguments, we already know the formula of arguments. Okay, so the argument of z is nothing but theta plus 2n pi, right? So theta is equals to minus pi by 2 plus 2n pi. So this is your answer, and n must be plus 0 plus minus 1. There is some value also. So from these questions, I know this is a very easy questions, okay, but this is a basic. Okay, so problems is, so argument of z, options A and options B are the correct answer actually here. Okay, options A and B is the correct answer. So this kind of MSQ type questions many times IIT JAM, many IITs asked in your previous year exams also. Okay, I hope you feel those questions are very easy. Okay, that's then fine. Then it means you understand the difference between arguments and principal arguments, right? If you feel it, okay, sir, it's very easy question. Yes, I'm also very happy. Okay, try to understand the next part. Yes, this is the kinds of corollary, and here is this basically I'm summarize. I'm actually here the summarize the part. Okay, so let z1 and z2 be two non-zero complex number, right? This is basically to come to non-zero complex number, and the argument product of z1 and z2, this is kinds of argument of z1 plus argument of z2 and 2n pi, and n have some value also we had discussed. And then argument of quotient, so this is equals to argument of z1 by z2, it's nothing but argument of z1 minus argument of z2 plus 2n pi, and n also same value. These are the two important case. So multiplication of complex number adds the angles, okay, and division subtract the angle in argent planes. Okay, this is a kinds of definitions. I hope you understand better. When you multiplications of complex number, you add the angles, okay, and when you subtract the angle, you get basically divisions of complex number, and then calculate the arguments. Okay, this is a very simple case. You have to note here. Yes, it's a kinds of very good questions. This is in order to find. Okay, there are some problems, so don't worry about that. In order to find the principal's arguments, okay, you have to calculate the principal arguments when z is equals to basically that. When z equals to basically that, how you can calculate this kind of problems? So let's try to solve that. So basically z, okay, yes, z is equals to minus 2 1 plus root 3i. Okay, so to calculate the argument of z, okay, argument of z, we want to calculate the argument of z. So basically argument of z means argument minus 2 upon 1 plus root 3i. So just follow the quotient formula. Okay, so it means principal's argument minus 2 minus principal argument of 3i. So let us consider here z1 equals to minus 2 and z2 equals to 1 plus root 3i. You just calculate the principal argument of these two complex numbers. So it is nothing but minus 2 plus I0, right? And it is equals to, already this is a very easy case, right? So you just calculate the theta, right? So principal's argument of z means theta, and theta means tan inverse y by x. So principal's arguments of 2, okay, 2 minus 2, it means theta 1, and it is equals to tan inverse y, it means 0. Okay, it's 0, right? Okay, and again argument of z2, it means theta 2, and theta 2 is nothing but tan inverse root 3 by 1. So tan inverse root 3, it means tan inverse root 3 60 degree. So 60 degree means pi by 3. Okay, pi by 3. So finally we got the answer. So principal's argument of z, it means arguments of 2, principal's argument of minus 2 minus principal's arguments of 1 plus root 3i. Okay, so that is equals to 0 minus of pi by 3, and that is equals to pi by 3. I hope again this is very easy questions for you. Okay, so this is the principal's argument. In this way you can calculate the principal's arguments of any kinds of complex number. Okay, next try to solve the another questions. Yes, it's a very good questions. This questions is basically asked in IIT JAM 2023. Okay, this is the questions asked in 2023. Okay, so the questions is the roots of the polynomials. There are given some polynomials. Okay, so the fourth order polynomials. So these polynomials have four kinds of roots. So z1, z2, z3 and z4. And then which of the following statements each correct? Okay, not statement, it's a kind of one statement. Okay, it's MCQ questions, not MSQ, sorry, this is MSQ question. So this is not statements. Okay, this is a kind of statement. Okay, we just follow the following we already know the relations between root and quotient, right, for any kinds of polynomials. Let's say fourth order polynomials is given, so z to the power 4, okay, plus a1 z1 cube, a2 z square, a3 z plus a4 equals to 0. This is the kinds of fourth order polynomials. So we had already relations between the coefficient and the roots. Okay, so use the relationship between roots and coefficient. So the sum of the roots, okay, sum of the roots, it means sum of the roots means z1 plus z2 plus z3 plus z4 is equals to basically minus a1, and the product of the roots it means z1 z2 z3 z4 is equals to f4. Okay, so a1, just from the given polynomial, a1 is nothing but minus 38, so it is equals to minus of minus 38, so it is equals to plus 38, and a4 is equals to 26. Okay, you just calculate. This is actually match with option D, right? So just calculate Z1, Z2, Z3, Z4 on product of the roots and the sum of the roots. This question is a kinds of question. So 26 by 38, 13 by 19. So option D is the correct answer, right? So option D is the correct answer. So this is again another very easy questions asked in IIT JAM 2023. Okay, next start with another questions also. Yes, this questions asked in IIT JAM 2025. Okay. So the questions is here given is a kinds of complex number, okay, complex number, and you have to find the value of n actually. Okay, this is again very easy questions, so try to solve that kind of questions in step by step. Okay, so here given 1 minus I, 1 plus I. Okay, you just rearrange this, multiply with denominator and numerator with 1 minus I. Okay, so in the numerator part we get 1 minus I whole square and numerator 1 minus I square. So okay, that is equals to 1 minus 2I plus I square and 1 minus minus of 1. So it is equals to 1 minus 2I minus 1, and that is in the denominator part 2. So 1 cancel each other, so you get minus I. Okay, so 1 minus I and 1 plus I is equals to a simple complex number, z equals to x plus y. So your main aim is convert. So you have a, let's say you have a some value z1 plus by z2. So your main aim it is convert to a some complex number x plus iy format. Okay, then it is easy to convert this expression in a polar coordinate system and then use the Euler's formula and solve it. Okay, समझ आ रहा है ना मैं क्या बोलूँ, तुम्हारे पास मान लीजिए Z1 और Z2 के फॉर्म में कुछ कम्प्लेक्स नंबर है और तुम इसको पहले एक x प्लस आई वाई के फॉर्म में इसको एक्सप्रेस करो एंड देन उस फॉर्म से कम्प्लेक्स नंबर का तो पोलर फॉर्म में e टू द पावर आई थीटा के फॉर्म में उसको कन्वर्ट करो एंड देन यू कैन कैलकुलेट any kinds of value of n. So now okay, so what do you get? Minus I whole to the power n by 2 equals to minus 1. So minus I is nothing but e to the power minus pi by 2 whole to the power n by 2, and minus 1 it is equals to e to the power I by pi. So it is equals to e to the power minus I n pi by 4 equals to e to the power I pi. So just comparing each others. So n pi by 4 equals to pi and n equals to 4. Okay, so the correct answer of this question is basically options B. I hope you understand. Okay, so those are the some important topics. In the next class we have to discuss the analytic functions. This is also again very important. So we have to discuss a theory as well as the some problems also. So that's why you have to understand properly each of the part in details. Okay, so today's class is end here, and thank you for watching these videos. If you feel this video is very important, just share your friends who are in semester 4, okay, and also your all friends who are willing to interest, they're very willing to understand the concept of complex number. Okay, and my lectures is totally focused on this Vidyasagar University course and also the national level exams, IIT JAM, JEST and TIFR, not any other university. Okay, if in the semester 4 they have a complex mathematical analysis, and in the mathematical analysis complex analysis part is there, then okay, fine, they can choose and they can learn from these channels also. So I have no complaint. But those students in the semester 4 they have no mathematics, so this course is not for you. Okay, I hope you understand better. So thank you again, thank you, and keep learning and stay with the channels. Okay, thank you.